Hello, and welcome to my computer science project walkthrough and example video. The best way to explain the code, I think, is if I go ahead and run it and then walk you through what's going on here. So I've run it previously, so I'll just show you. So we click run, and we actually need to make sure we're executing the right part of the code. So we click run. Sorry, this is Jupyter Notebook, so you can click on different cells and run them, which is why the box didn't pop up until I clicked on this cell. Right, anyway, back to the top. Boop. Right. We can click this button and make some art, and I use that word sparingly, but we can make art by clicking this button. So why don't we go ahead and get a picture, a new picture, one I've not used before, and see what we can make. So let's do something arbitrary, something different. Let's get a door. Let's get a door. Right. There are lots of doors. I like this door. This one's pretty cool. Ah, look at this door. This one's got lots going on. Now this door is a very large, this is a very large image, and I will tell you later while it's not good to use a very large image. The ideal image we want is perhaps a smaller image. Something like this. This is a pretty cool looking door. Let's go for this image. So we save that image. And yes, these are our previous arts that we've made. If we save our image like that, right? So we have a door. Now we're going to go ahead and make our own art. We can go and we can see that door. We can click on our door, and we scroll down here. Right, notice how it's got the door loaded in. The door is now loaded into the memory. Now you'll notice that we are starting to use quite a lot of memory. We're using about 6 gigabytes of RAM. That's with this running and obviously other Windows processes. Also notice our CPU utilization. It's gone gone very high. We have it can go up to 80% utilization. However, I've managed to overclock my CPU a little bit more, so your performance may vary. Now, yes, let's talk about what this is doing. This uses the Google Deep Dream API and our own neural network to make new art. So our neural network is just these 3 neurons here, okay, using TensorFlow. However, it's pre-trained on the Google Deep Dream API. We don't have to train it ourselves, which is why it's very effective. And we can have this image. Now, this is almost finished. Memory's creeping up. CPU utilization is as well. And in a minute, this will just output the image as it is, and we can go on from there. So this project does 2 things. Not only does it generate art, it's also able to identify art that it's made using another neural network. The other one that identifies the art is much more complex and is this one here. So this has many more neurons, such that it's a lot more adept and able to identify art that it's made. Now, I believe this guy has finished, and there is our new image of a door. Now, if I go ahead and save that image, and I put it in the AI art folder, we can go ahead and call it door. There it is. We can see how it compares to the image previous. So there's our old blue wooden door, not blooden. That doesn't make any sense. Old blue wooden door. Right. Let's click properties. So this door is about 25.8 kilobytes. It's quite small. But this door, the door that we've made, is 1.12 megabytes. Now, if we used a larger image, a 4K image, it would be even bigger. And we run the risk of running out of RAM if we were to iterate over the image multiple times. You'll notice that there was a previous little number 6. That indicates how many times we've passed the image through the network. We went through 6 times. Now, if we went through, say, 25 times with a 4K image, for example, we'd run the risk of running out of memory. And that would be very bad for system stability, obviously. Anyway, so here's our the difference in file size, night and day. What we can do is, why don't we actually look at the door that we've made? So that's the door we haven't made. It's quite small and not very good. And there's the door that we've made. Notice it's much larger. The file size, well, sorry, yeah, I've already said the file size is larger. You can also zoom in a little bit. It's a little bit blurry still because it was a smaller image, but that's very usable. Notice how the chair leg has changed such that it's not the same color anymore. Previously, let's get rid of you. Right. Previously, the chair leg was sort of going sort of backwards and the other way. Now the chair leg's going forwards this time because that's what was deemed necessary by the algorithm. There's lots of different faces and eyes. It really likes eyes in this image. So if you were my target audience, making an album cover, you can zoom in, go onto like a chair or something, zoom all the way in, get to like this guy, and then boom, there's an album cover right there. Better than that one. This does mean that you can zoom in quite far and still retain the same the same quality of the image. Right, let's get rid of those. That's our chair. Oh, and we'll get rid of these guys too. There we go. Now, the next thing I'd like to show you is the image identifier. We're able to identify images we've never seen before. So, let's go to the training data file path. Now, this I've made it so you can enter it manually if you so choose. So, images, let's spell images. Oh, good lord. There we go. Oh, just having a little bit of a brain moment. Right. And let's go to test. Right. So we have our training data and our testing data. We start the image identifiers. Now, this is quite cool. First, it shows you an example of images we are training on. Now, this isn't the entire dataset. This is only 5 images. So if you had a dataset that was 1,000 images long, if you were using a more sort of larger dataset, it would only show you 5. It just shows you a little handful so you can see what kind of images we're working with. Now, we iterate over this 90 times, which is quite a lot. And you'll notice our loss rate has gone down pretty quick. So I reckon we're going to be somewhat accurate on this. It iterates over these images 90 times, and it can tell you whether it's images we've made previously or images we haven't made. So see this child, we haven't made this image. This image was one that we just downloaded and put it into the training data as a not generated image. But does it know that? Is it able to learn that? And so we'll just go up and I will show you that. Okay, so we start from an image. So first, the way it works is we pick an image, we format it into Unit 8 formatting up here. We make it 59,536 by 160, so we can then scale it down to about 3 possibilities, and one of them is a blank. So it can be either or. Now we use this number because it's 2 to the it works as like a 2 to the power x without being sort of too crazy big and causing errors with poor Python. Right, so we were 83% accurate. This is pretty good. So out of all of the images that we saw here, it was actually, I believe it was, yeah, it was completely accurate. Notice how it says generated, generated, generated. So the first 3 ones that we have made, and that is true. These look terrible. And then the next one was not generated. That was the picture of the child there. Yep. And then we have generated being the last one. So you've got the picture of the child in the shirt there. So out of all of the images, we are only 83% accurate. However, out of the images we picked, we were actually quite accurate. Now, sometimes this can be different. We could be, for example, 60% accurate, and perhaps out of the images, it would still be they might be all wrong. So if that's the case, then we'd have to say, right, we need to iterate over the images more. So let's show where the images are kept. So we go to images here, and we go to test and train. So this is the testing data and the training data. So we're training on, so we're saying, right, say this image, the child, and this person here, right? Notice how this person wasn't like in the pop-up. It just takes a handful. And in our training data of generate, oh no, not generate. In our training data against generated, we've got this image it's never seen before. That one, that one is a very large image, so I'm surprised it did very well. We have this one. So we have tons and tons of images. We have a cat here, that one, etc. Right. When we look at our testing data, we have, for example, we're testing it on an image it's seen before, but we're also testing it on images it hasn't seen before. Now, due to how few images we have, the fact that it was able to get 83% is... Oh, that's already... Boop. See, we also have this cat. So we have a picture of a cat and a picture of the cat after it's been through the neural network. So it was able to be fairly accurate against all of the images. It was 83% certain of its choices, of itself, and it actually did that very well. So I think that's quite cool. Now, it's important that in our testing and training data, we have a mixture of images, some of which it might have seen before. That way, we can tell if it's learned. Has it seen the image and understood it? So that was how my code works, and a very brief dive into the neural network as a whole. Thank you very much for watching, and I hope this was informative. Goodbye.